Have you ever really wondered what's going on under the hood to keep your computer safe? It's a lot more than just some antivirus software, you know. Today, we're going to peel back the layers on modern Windows security to see how it's really built, from the silicon chip itself all the way up to the cloud. So let's pull back the curtain and see what's actually going on.
This quote from Microsoft, it just gets right to the heart of the problem today. See, the game has totally changed. It's less about someone smashing through a digital wall and a lot more about them just tricking their way in through the front door, using stolen keys. This changes everything. So how do you defend against an enemy who looks like they belong there? To answer that, first we've got to understand the world we're living in right now, because the threats today, they are not the same ones we were dealing with even just a few years ago. We've all seen these, right? That email from your bank that urgently needs you to verify your account details. These aren't just random annoyances anymore. They are super sophisticated, targeted attacks trying to steal your identity. They're going after the weakest link in any security chain, us, the people. So how do you even begin to fight something so widespread? Well, you need data, a truly mind-boggling amount of it. The scale of this defense is just staggering. This number, 100 trillion, that's how many signals Microsoft analyzes every single day. We're talking signals from emails, from logins, device activity all around the world, creating this massive real-time map of all the threats popping up. Okay, so with all that global intelligence working in the background, let's look at the first layer of protection. This is the one you and I actually see and use every day. For years, we were all told the answer was just more complicated passwords, right? Add a capital letter, a number, a symbol, make it 16 characters long. But the new way, the way that's built right into Windows, is just smarter. It moves away from something you know, which can be stolen, to something you are. This is Windows Hello, using your face or fingerprint, and passkeys, which use your phone to log you in. It pretty much kills the risk of phishing. And you know what? This new approach really, really works. Businesses that have actually adopted these modern security features in Windows 11 have reported a staggering 62% drop in security incidents. That's not just a small improvement. That is a total game changer. And we can get even more specific. The key thing to get is that this isn't about one single feature. It's about a whole combination of protections all working together. And the result? A 3 times reduction in firmware attacks. We're talking attacks on the machine's most basic software, and almost 3 times fewer cases of identity theft. But here's the thing, user-level security is really just the tip of the iceberg. The real strength of this system goes much, much deeper. We're just getting started. Let's dive in and see how this all connects. This is a really fundamental shift in how we think about this stuff. For the longest time, security was just an application you installed on top of everything else. It's kind of like the difference between hiring a single security guard for your front door versus building the entire building with reinforced walls and an alarm system built right in. Real security has to be baked in from the very foundation. So take a look at this. This is basically a map of that entire security system. Now don't worry about reading every single box. Just get a feel for the structure. Down in the very bottom, you've got the physical hardware. Then you've got the operating system, the apps, your identity, and then finally, the cloud services. Each layer is built with security in mind and designed to protect the layers sitting on top of it. So what's actually happening at that foundational hardware level? Well, you have these specialized parts like the TPM 2.0 chip and the Pluton security processor. Think of them like a secure vault built right into your computer's main chip. They create something called a hardware root of trust. It's like the concrete foundation of a skyscraper. If that foundation is rock solid, the whole building on top of it is just way, way safer. Now, this deep integration of hardware and software, it doesn't just happen by accident. It's the result of a very deliberate philosophy and, more importantly, a super rigorous, non-negotiable process. This is the core idea right here, secure by design. It means engineers don't build a product and then ask, okay, now how do we bolt on some security? No. Instead, security is part of the initial blueprint. It's a completely proactive mindset, not a reactive fix. But you know, a philosophy is just words without a plan. So how do you actually make this happen across a company with tens of thousands of engineers? You create a mandatory process. And at Microsoft, that process is called the Security Development Lifecycle, or SDL for short. And this slide really lays out that journey perfectly. This isn't just a suggestion, okay? Every single product has to go through these 7 phases. It starts with training engineers on secure coding. Then it moves to defining security requirements before a single line of code is even written. Then, during the design phase, they're actively trying to break their own ideas. This discipline continues all the way through implementation, brutal verification tests, a careful release, and even a plan for what to do after the product is in your hands. This process itself is a huge deal.
Okay, so we have security that's built in from the chip up, following this strict internal process. But how do we, the people on the outside, know that it actually holds up? That brings us to our final and maybe most crucial layer, independent third-party validation. So meet FIPS 140. It stands for Federal Information Processing Standard, and it is an incredibly high bar to clear. This is pretty much the gold standard for security. It's a U.S. government standard used to validate the cryptographic parts of the software, the bits that handle all the encryption. Passing this audit is a very, very big deal. Now, you are not meant to read this table. Seriously, don't even try. Just look at it. The whole point is to give you a visual sense of the sheer exhaustive depth of this whole process. Every single one of those lines represents a specific crypto module inside Windows that has been independently tested, scrutinized, and certified to meet that gold standard. The level of detail here is just immense. So the bottom line is this. When you hear claims about Windows security, it's not just marketing speak. It's a system that's been designed in layers, from the hardware all the way to the cloud, guided by this secure by design philosophy, and then proven by some of the most rigorous independent testing on the planet. Which kind of brings us to our final thought. The world of threats never, ever stops evolving. Work is already happening on things like post-quantum cryptography to defend against computers that don't even exist yet. It leaves us with a pretty big question. In a world of generative AI and quantum computers, what does the security onion look like in 5 or 10 years? What's that next essential layer of protection even going to be? What do you think?